Hey guys, it's Terry. Wanted to share with you guys my unboxing and first programming of the Parallax P2 engineering sample. There were about 100 boards created for these, sent out. And you could purchase them from Parallax if you're interested in the Propeller 2. Let's see here. Yep, okay. Well, I hope my video is streaming. We'll find out. This could be rather embarrassing. Hopefully it'll get recorded. So let's go ahead and get this bad boy opened up. I ordered this using UPS during, it was shipped just before Christmas. I have now learned to not ship via UPS during the Christmas season. Regular ground from Rockland, California. It took, I guess it was 2 weeks to get here. It goes like this. Here we go, yay. Got your standard packaging in there. Ooh, we have our anti-static bag with our P2 evaluation board. And we have our invoice. So, this could go very badly, and if this never shows up on Facebook again, that's because it did go badly. And I'll be completely embarrassed, but I don't care. All right, so put this up here for you guys to see. It's the P2ES evaluation board. It is one of the engineering samples from the first batch of Propeller 2 chips that were manufactured by ON Semi. They did a wafer board run, and they went ahead and packaged some of the wafers. There we go. Here's our board. Aha! And we have our feet that are stuck down in the package. We pull these guys out. Yay! Feet. I guess that's probably the first thing we ought to do is put our feet on. Now this is an amazing little chip right here. It is different than the Propeller 1. So to tell you guys a little bit about the Propeller 1, it is an 8-core microcontroller with 32K of RAM, and it is a 32-bit microcontroller. And the Propeller 1 had, I believe, 32 general purpose I/O pins, and this, I believe, has 64 general purpose I/O pins. The P1 ran at 80 megahertz. They could reasonably squeeze more than that out of it. You can get 100 megahertz out of it stable. This right here, some people have been running at 300 megahertz. And so there is the new P2 chip, if I can get it to focus. Board's so shiny, I don't think I'm going to be able to. Look at that. Okay, and so this is the eval board. And it is from Parallax. So Chip Gracie is the guy that designed this. He had a whole lot of help from folks online that were helping tweak it with the VGA with the FPGA boards. I would have loved to have participated in that, but to have a properly running chip required a very expensive FPGA board, which, you know, is about 5 times the cost of one of these. You're spending between $500 and $1,000 for those FPGA boards that were fully featured and could run the P2 at 80 megahertz. Additionally, I didn't have the time, so I got 2 little ones, and don't have the amount of time that you know needed to be able to produce anything useful for those guys. So I kind of held off on it. Another difference with the P2 as opposed to the standard propeller is these have a feature known as smart pins. So you can program the smart pins to do all kinds of things. They can accept data in, serial data in to the pin, and essentially shift register it, you know, into a parallel form where you can just grab the byte, and so you don't have to sit there and bit bang like you did with the original propeller. With the original propeller, everything was essentially a soft. They didn't have specialized hardware. Everything was configurable via software, and basically you had soft peripherals that you would configure them for serial or your DACs, you know, any of your Sigma Delta stuff, all of that type of thing. So the smart pins are the next logical step to that. Basically, you're pushing a lot of the things that you were occupying the entire core of the P2 to do out to these smart pins. Like the original P2, this has 8 cores, or cogs as they're often referred to. I think that they're probably going to change the cog paradigm to cores because that's what people understand, and you know that makes good sense. The other thing that the P2 has that the original propeller doesn't have is interrupts. So I know that a lot of people don't understand how you would be able to program a microcontroller or do anything useful without interrupts. Well, whenever you have 8 of them that share memory, that share a common RAM, you can do all kinds of useful things, because pretty much most of your microcontrollers only have a handful of tasks that they perform. You know, with the propeller, one of the important tasks that it could do that was really cool is it was able to produce video. So, you know, NTSC and VGA video, it could produce easily. You just assign that to a cog, and off it goes, reading your RAM and producing the video that you want. And then if you want to manipulate what's on the screen, you would just use another cog to do that. And you know, it made doing stuff like that very easy. I mean, you didn't have to be a rocket scientist or anything to go from 0 to having stuff put up on your VGA screen. I found it much simpler to do than many of the other microcontrollers out there. I know a lot of people really enjoy their Arduinos, but the Arduino's capabilities just seem very limited compared to what the propeller could do, at least to me. Well, anyway, let's go ahead and get to programming this thing. I do not know if what I'm about to do will work. I don't know. I don't have any idea as to how to program one of these. It's only academic for me. They have currently the tool chain for this is pretty much either something that is voluntary, that has been built up by volunteers. I believe there's a C compiler that's got a lot of progress on it. There's FastSpin. I've even seen where one of the compilers does BASIC. Most folks that are in the development part of it, they use, you know, they'll use assembly anyway. It's called PASM, P-A-S-M, is what's typically done to program these. I will say that the assembly language on the propeller, and based on what I've seen, the propeller too, is awesome. I mean, you can have conditional execution based on flags, which I just can't tell you how cool that is to me. It's a paradigm that probably is available on other microcontrollers, but I haven't seen it. Just the ability to grab a result and then have the next line execute conditionally if the C flag or the Z flag's been set. Man, that's just cool. There's all kinds of cool stuff you can do with it. So I'm going to go ahead and plug this thing in, and we'll see what we get here. I do have an app up called it's called Blink All Cogs, and so it should blink these LEDs. If it doesn't, I apologize. Again, this is the first time I've powered this thing on. Let's see here, let me make sure. 50% of the time you get it right. Not really, you get it wrong every time. Okay, well, we've got this guy plugged in, and there's a couple of LEDs on there, and saw some stuff come up. So let me go ahead and swap over here. And I don't know if you'll be able to see that or not. Try to zoom in there. We'll see how it goes. So I'll go over here. I'll tell it to run and load PASM. Oh, no hardware found on COM 1 through 9. That is my error. Outstanding. Okay, well, let's open up and find out what it got assigned here. That is going to be in Device Manager. Again, this may be a complete failure. I guess we'll just have to see. All right, COM port 10. Well, that would be why. Let's go to the properties here. Go to our port settings and go to our driver detail. Why did you come up as COM 10? Advanced. No, we don't want COM 10. How about COM 2? There we go. Okay, so let's try this again. Compile and run. Hey, loading RAM. Okay. Had a couple lights come on and then turn off. I do not know if I even have the jumper set correctly here. So that's the other thing I need to look at. And well, all the lights went out. That's different. Okay. Well, I did download. Let me go over here and do this. In the downloads area. if I'm not able to make this go, well, I'll just do another video where it does go. All right, all cogs link spin 2. All right. Compile and execute. I got nothing. Well, it looks like it's programming, but I don't have much going on here. Okay. Well, it could be because I've got this thing set to boot. From micro SD possibly. That's interesting. We'll reset it one more time. See how this goes. And if it's a no-go, then I'm probably going to shut it down here, and we'll come up with something else. There's very limited documentation on this, so no, I haven't seen anyone actually put up a how-to or anything like that, so I was kind of hoping that I'd be able to get this thing to work right out of the box. That does not appear to be the case. Okay, well, there's that. Looks like I need to go read some more. Anyway, let me go ahead and bring it back up over here to the overhead again. So hopefully I'll be able to show some cool things that this can do after I go learn some more. Totally not surprised that I'm getting my butt kicked by this. But that's okay. It is an engineering sample and it is an evaluation board, so you really it's definitely not your just go download the software and press the button to make it say hello world. It's probably going to take a little more than that. I'm sure I probably have the dip switches set wrong, or I've done something so that the so it's not booting properly from the onboard SPI flash. So I don't know. We'll figure it out one way or another. But I've been super excited about this thing. I've been following the development of this chip for years. They had a failed attempt many years ago, and they had to scrap the whole thing and start all over again. And this one appears to be pretty good from what I've seen. They've been able to excuse me. They've been able to produce HDMI with these, so you can do HDMI video out of it. I've seen it where it'll act as a USB host controller. It'll do all kinds of things, and it can do it all at the same time, which is really cool. Ultimately, I think a lot of people want to be able to build a self-hosted environment for the P2. So essentially, you boot into the P2 and then you do development on the P2 with the P2, which would be kind of cool. Other things on here. Oh, look at that. I do have flashes. That's very interesting. Okay, I got all kinds of flashes going on. I don't know what happened there, but neat. It does have SD card boot. So you can boot from SD card. Additionally, there is a built-in. There is a sort of a built-in type of OS on here called Tacos, and it's based off Tachyon, which is oh, I'm drawing a blank right now. I'm kind of tired. Haven't caught up from being on vacation and my whole sleep schedule being destroyed. Boy, I cannot remember what that is. But essentially, it's a way for you to log in with Serial. You can tell it to produce square waves and out of the pins, or make it produce sine waves out of the pins, or have it do any number of things. So I'm going to fool around with that, see if we can get it going. I'll put up another video. We'll see if the Make Nashville guys enjoy this. If you guys do, I will produce another one where this does something useful and I know more. So take care. I appreciate it. And we'll see you later. Bye.